Hello and welcome back to my channel. This session today will be about running a remote application onto a node on the HPC cluster and have an interactive access with it using your own laptop. So without further ado, this is the content for today. So here you can see a normal remote access configuration. Here we have the home, the laptop at home over the internet, and then the office with the HPC cluster sitting somewhere on that network. So we're used to the idea of creating ourselves a VPN tunnel onto the black network. This is fine. The next stage after you're going to be SSHing or connecting over SSH to the head node of the cluster. A few words on the principle behind an HPC cluster. Generally speaking, the work is done on a schedule basis. So you request to the resource manager to run a specific job. In our case, that resource manager is called Slurm. So if you need to read up on some of the documentation, this is informative to know. Then the job will get started on your behalf on a compute node, which means for us an extra hop to get to any processes that might be of interest here. The scheduling is subject to some constraints. So in our case, we have a maximum runtime of a single for a single job unit is going to be 48 hours max. Priority is going to be implemented using a fair share algorithm. Basically what it means is depending on your project you're working on, you may have different priorities. So in general, an HPC cluster is not meant for interactive use. We're going to overcome this and work around this principle here to gain access to a node with GPU capabilities for exploratory work using a Jupyter notebook. In the mid to long term, aim for decoupling from the Jupyter environment for executing and computing. This will make your life much better because you may have to wait from time to time if there's a lot of jobs being waiting to run. You may feel that you have to wait for your job to run for some time. Here's a different view of the same workflow. So we log in first, assuming we're already logged into the head node. A user will submit a job, and then Slurm will respond with a job ID. The job will eventually start onto a compute node assigned by Slurm that will satisfy the resource request that you have included in your job script. At that time, the compute node will just go ahead and run your job. In our case, JupyterLab Jupyter Notebook invocation does not finish. So it will be either that the timeout is reached or we issue a cancel on that job ID, whichever comes first, and then the job will just be torn down. This is pretty much every time what's going to happen for a job that you will start. At any given time, you can query the scheduler for information about specific, like the queue, wait time, and things like that. You can actually inspect that at your leisure. Okay. So again, the same information in a different view. So we have, we're already connected onto the head node. I changed a bit the representation here to illustrate the compute node environment. So a user, in my case, I just scheduled a job using sbatch. The job, the scheduler returns to me the job ID. At a certain time, the job gets actually scheduled, and you can inspect your logs, and you will find, in the case of JupyterLab, it will output the location where it's running. So this is all fine. We're all happy. We have a Jupyter notebook running somewhere, but how can we reach it? That's where handy feature of SSH client comes handy. So we're going to leverage SSH tunnels to get there. So what is an SSH tunnel? Is essentially a port mapping between the local machine and a certain destination. So here I'm going to show you in PuTTY how we do this. If you use a different SSH client, it's going to differ, but the same concepts apply on all clients I've seen. So assuming we have a connection over to the head node, like this is the case in my screen here. What you want to go for is to look at the change settings. This could be also saved in your session, but we'll discuss this a little bit further after this section. There's some dynamic aspects to these, so you may not necessarily want to do that. So what you want to look for is in the SSH section, you have tunnels over here. That's where you can define that tunnel. So the source port, on our case, on our laptop, I will assume that there's nothing holding port 8888. Depending on your configuration, this may or may not be working. It should be okay. And what you want to do for your destination is look at the log of your job, and Jupyter will output, like over here, it will output this information over here. So that's what you want to type in here. In our case, it's running on a compute node 108 on the port 8888. And this is not out of coincidence that I use the same number on both sides. I'm going to show you why in a second. So after clicking add, you need to click apply. And if you don't do this, the port is not going to be mapped. So over here we have created that tunnel, and what I want to show you is a typical output of a job. So in my case, I want to look at the last time I ran this example here, and as you can see over here at the very bottom, that's what I mean here, okay? But for our convenience, the way that the output is written, you also have this version over here. So the nice thing about this is this will be coherent with your tunnel, because 127.0.0.1 is the same is the IP of the local host host. So by copying and pasting this URL, you'll be connecting directly to JupyterLab. I won't do this here because it's a simulation. I actually have nothing running on that compute node as we speak, but that would work. Okay, so coming back over to this the screen here, a few words of caution. I hinted on this earlier on. A job will run on the next or a compute node. You don't necessarily know ahead of time which compute node this will be, so that's dynamic by design. An HPC cluster generally will have much more resource on a compute node than what a single job will require. So it's very possible that your job might coexist on the same node as a different job from a colleague of yours. In which case, the port number, if there's another user doing the similar thing as yourself on the same node, it could happen that the Jupyter notebook runs on a different port number. So keep in mind, this could be dynamic also. And unfortunately, PuTTY sessions, if you save them, those tunnels are defined statically. So keep that in mind. You may have to modify them if you come back at a later day and you resume work. It may not restart on the same exact node with the same exact port. This can easily become cumbersome, as you can tell, but this is still very flexible currently. We're able to perform tasks like this. JupyterLab, I mentioned this already, is designed in a way that it will automatically try the next port number if this were to be already used. But then again, I mentioned that, but the port would be dynamic, so you would have to edit your tunnels to match. If it becomes too cumbersome down the road, we could decide to use a flag to JupyterLab to start on a given port number. This could be used to alleviate those collision issue if there's a lot of those happening, but for now this is not implemented. Okay, so I will end for this session now. In a future session we will go over these the real requests and simulate, or not simulate, but actually show you how to interact with JupyterLab. Okay, thank you, and see you next time.